So if anyone will ask you in the question in the interview about this, what is the specific gravity of the sand? He did not ask you any reference. He just asked you randomly that what's the specific gravity of the sand. You can tell it 2.64, 2.65, because it is the most common value coming in most of the trials. So the next is the silt content. What is the silt content? Silt content is the impurity in the sand. How we will calculate it is the impurity of the sand. If it exceeds 6% by volume, for example, then you need to wash the sand. But in India, in our subcontinent, in the Asia, the sand is very fine because we have the large tributaries like the Ganges, Indus valleys, Chenab. We have a lot of, so our sand is quite fine, and so the silt content always found being less than 3% or 4%. So if any interviewer, if you in future you will get any question regarding the silt content of the sand, if anyone will ask you that the sand found in our India is having the silt content of more than 6% or less than 6%. Without thinking anything, you can go ahead with less than 6% because the most fine sand being found in the India. Okay, this is the same process of the like this gradation of the fine aggregate. Now it is the coarse aggregate, same, but the size of the sieves starts from 20 mm to 4.75 mm. So the last size what I told in the fine, so you can clearly describe it like this. If less than 4.75 mm, it is fine aggregate. If it greater than 4.75 mm, it is coarse aggregate. Simple thing as it is. Okay, so this is the same thing what I make from that chart in the Excel on the log E10 scale, like how much percentage. This is fine modulus of 0, for example, 0 passing from the 20. That means aggregate is less than 20 mm. Then in next C, it is 88%. That means 20% 12% retains there, and then in next C 99.39, and then after that it passes all along, and it is 6 fine modulus 6. Same thing like specific gravity of the fine aggregate. You have to find the specific gravity of the coarse aggregate, and in that case we don't use the apparatus picnometer. We put the this coarse aggregate in a glass in a tub like a basket. Okay, and we put that basket in the water for 24 hours, and then we make it the saturated surface dry for the next and then we deduct the weight of the two samples, and we will get the specific, and we will find the water absorption, how much absorbed the water, and we will find the specific gravity like that. For example, it is showing here weight of the sample divided by weight of sample minus own right. So this is slump test. Slump test, as we told you about this methodology, we read there in the slump test, Jaring test, V-funnel test. These are the tests being performed on the concrete. So once we are done with the cement, once we are done with the fine aggregate, once we are done with the coarse aggregate, so the next thing is concrete. We can mix this cement, we can mix the fine aggregate, we can mix the coarse aggregate together using the water ratio, and we can make a workable concrete. So before using the concrete for at the site, using design process, if you follow the design process, you have to do that procedure. You have to go ahead, go through this test, slump test for the workability tests. I mean to say whether it is a self-compacted concrete or whether it's not, whether it is non-self-compacted concrete. You have to go through these tests. So the slump test is the most common test. I think in the diploma, in the bachelor's, this test is being performed most commonly in all the sites. This slump test, compaction factor test. So the slump test is all about, we have the cone of the 30 centimeters, and if the slump test and if this slump comes less than 25 mm, it is the true slump. And if it comes up to 150 mm, I mean 15 centimeter, up to the half, it is a shear slump. And if greater than 150, it is the collapse. That means the failure of the concrete. So in the, for example, I put the example here of N25 concrete for the mix of 1. It's a design mix with the water cement ratio of 0.43. The slump is 50. So that means it is a shear slump. It's not a true slump. True slump is the hard, consistent concrete, and up to 150 mm, it is a shear, and if greater than 15 centimeter, it is the failure. So the next is the compaction factor test. It is the again like the slump test. It is being performed to determine the workability or the consistency of the concrete mix of the given proportion, whether it is the M25, whether M30, any kind grade of concrete. So the apparatus being used here is this compaction factor apparatus, and it's having the two hoopers at the top and the one slender, and we let the concrete let off by using by opening the flaps, and we put it, did not do any kind of compaction here. Just we put the concrete in the top hooper, just open the flap, it falls into the second one, then open the flap, then wait for 5 seconds, open the flap, and it goes into the cylinder, and then we put that cylinder sample, and then we check the workability, whatever it comes the compaction factor, and we'll check the workability. Yeah. So the last slump test and the compaction factor test. As I told you, two kinds of concrete being used, either the non-self-compacted concrete without using the super plasticizer, and the self-compacted concrete. Slump test and the compaction factor test being performed on the non-self-compacting concrete. I again repeat, non-self-compacting concrete is the concrete where there is not any kind of super plasticizer, or what I mean to say is the super plasticizer admixture. Admixture is the whether it's the retarding admixture, whether it's the super hardening admixture, whether it is the accelerating admixture. There are a lot of admixtures being used in the concrete. Okay, but nowadays the clients, large projects, they don't design the concrete on the site. What they do, they they give the details of the design to the ready mix plant, and they put the design there, and they order the concrete cubic for whatever they require the quantity, they order from the ready mix plant. Okay, and that concrete is self compacting concrete, that is the admixture is being used. So what are the tests being performed on that? For example, slump flow test. What is the slump flow test? It is again to determine the workability, and the slump cone is being used to, and and we put the circle on the surface, and then when we fill that cone, we lift it instantly, and we check how much for the the diameter, how much this it may concrete goes spread. If it goes beyond 700, it is very workable, and if it is less than 500, it is quite. And how much time it takes to spread the 500, and we check that. For example, in the main prime focus of this slump flow test is in the 5 second on the in the we put the circle of 500 centi, and we have to put the stopwatch in our hands, and we have to check how many seconds it takes the concrete to reach the 500 and if it takes, for example, in that case, for example, I put the 5.1 seconds to reach that circle. Okay, so the next test for the self-compacting concrete is the gearing test. It is the modification of the slump cone. The cascades are being used, and the when we put the concrete and that cone, and which lift that cone, and we again check that how much we put the circle of the 500, and we put see in the last we put 5.1. It takes 5.1 seconds to reach the 500 Okay, that was a slump flow test. That was not the gearing test. It's the gearing test. That means why we put that test, when you put the concrete in the columns or the beams, there's a reinforcement. Okay, when you put the self-compacting concrete, it's not open. There is reinforcement coming as the hindrance. So that's why this test being made, just to check when we put the concrete in the column how it goes. So it takes a lot of time, so there is need of vibrator to put it in the all. L-box test. This is again to determine the workability of self-compacting concrete, and the apparatus is the L-box, spirit level, and suitable box for, and you need to take the stopwatch. When you put the concrete from the top end, then you put the stopwatch in your hand, and then you check how much time it takes the concrete to come from the top to the bottom. And if only a half part comes, then you have that means, for example, I put here the passing ratio 0.85. That means the 15% is stuck in the top part, that the concrete is not workable. Next, again the V funnel test. As I told you, these four tests: L-box test, slump flow test, gearing test, and the V funnel test is being used for the self-compacting concrete. Okay, so the V funnel test, what we do in that part, there's a apparatus in the V shape. That's why it's called the V funnel. and it is 40 and 50 centi up from the ground. And when we put the concrete in the V funnel, then after that, what we will do, V funnel, then we will put there's a flap at the bottom. It is 65 mm, and then we check the stopwatch, how much time it takes to empty the whole the vessel. For example, in that case, for it take 8 seconds to empty the whole concrete. Okay, like this. In the we that what we learn from this all these four tests, that V funnel test, J ring test, whether it is a slump flow spread, what we learn that how much time it takes for the workable concrete to go to fill the volume. For example, if the beam is 300 cubic meter, so how much time it takes the concrete to fill that beam. So this is all about how much workable is the concrete, how much consistent is the concrete. So it makes the differentiate in between the two things, workability and the concretability. Okay, so after doing the tests on the materials in the cement, on the fine aggregate, on the coarse aggregate, and on the concrete, okay, then once we will done with the concrete, before going to the site, what we make the samples. For example, if we design the M25 or if we design the M30, when we design the M30, for example, that means 30 Newton per mm square or M35, we have to check that sample whether our design is okay or not. We do this thing on the universal testing machine to check the compressive strength. We put the load on the samples 150 by 150. You have done these tests, all these tests in the lab, but you have these are the most important things you have to keep in your mind before doing any process. So these are the sketch just I make in the AutoCAD about this, how retrofitting drawings are being made. You can see the internal part is the existing column, the white one. That's the existing column. As I told you that you cannot damage the column. You cannot retrofit the existing column to the original state. Not for example, if it is the 1 feet by 1 feet, you cannot make it like the same. If if the client's requirement is that you without increasing the size, then you can go to for the wrapping. But if there is a quite large space available, you can go with RC jacketing. It is quite economical process, but the wrapping is very costly. It costs around 5,000 per square meter. So the first is this RC jacketing without rebar, and in the second drive, what you check that the rebars are being drilled. So to make a firm hold of the new retrofitting steel cage with the existing steel. And in the third, it is the ferrocement jacketing, just the steel wire mesh being on this ferrocement jacketing is mostly used in the masonry walls. If you find any cracks of the existing structure, don't fill the grouts. It is useless. It will last for just 20 days. It will last for 1 year. It will last for maximum of 2 years. But the ferrocement jacketing will last for 10 years to 30 years. So about the current trends. What are the current trends about retrofitting and the rehabilitation being done in the existing structure nowadays? There has been the healthy growth in the building activity over the past decade. And there is no doubt about this thing. We have seen that how Dubai grows. In the 2002, there were only 2 skyscrapers, and now about 125 skyscrapers are there in Dubai. Just in 10 years, how Dubai changed, how Dubai transforms. So there is no doubt about it. However, recently the construction industry has been devoting more effort for the rehabilitation of the old buildings. Exactly, that is the motive, that is the objective of this today's webinar. That nowadays, what the engineers are primarily focusing on the retrofitting or the rehabilitation of the existing structures. They don't prefer the formula of demolishing the structure and making new skyscrapers. They want to save the money. They want to make a cost budget ratio. They want to make a good use of the land. They want to make a proper use of the land without demolishing the existing structure, without making the use of money. There are several reasons why fixing up older buildings being crowded. Yeah, exactly. There are several reasons. I will tell you. Go ahead. I will tell you in the next slide what are the reasons that fixing up older buildings is better option than going for the new construction. As our country, India is most populous, is the second populous after the China, and the population in the developed countries. This is about the developed countries. Developed means US, UK, Europe. India is still developing. and the developed countries have already started the process of retrofitting. So what about India? We are going. There is a lot of scope for the retrofitting and the rehabilitation in the India, as it is the developing country. It's not still yet developed, but in the developed country like New York and the West, any country, what a number of employed workers in the economy has followed suit. They are right now what they are doing. They are repairing the existing structures. They are making a plan for the next 50 years. Which structure has the design life? For example, if they have designed the New York tower back 30 years, nowadays they are making one sample list. They are making a list of all the buildings, and they are noting the things, how many years left for this building, how many years left for this building, because they will focus on that thing. And India is still going for the next new structures, new buildings, all that. So they are making a plan. The developed countries are already making a plan to repair the existing structure. They are collecting the data, how many skyscrapers we have. For example, the world tower was constructed 50 years back, so it was already over designed. For example, the 50 years have gone. It is the life of the design life was 50 years, so it has gone. So how many years left for the another structure? So they are planning, like they are planning things. They are doing these plans. They are making a list. Right now they are doing these things. Due to the slower growth in new employees, the new office buildings is less. So this is this is for the IT section, not for our field. But being a structural engineer, being a civil engineer, we can go with this thing also, that new office buildings are being constructed very less due to the slower growth. And renovation, that means that renovation of the older buildings, renovation of the older buildings increases due to the this slower growth of new employees, a lot of unemployment. And this retrofitted these structures can be retrofitted with the technologies that may make them as efficient as the I told you, to restore its original state, thereby producing a double benefit for our environment without making a waste, without making the damage, without making the air pollution, all that things. So we have done the part of the introduction, we have done the part of the overview about the process of retrofitting and rehabilitation. We have done the methodology, we have done the process, how it's gone, and we have done the current trends, what is happening right now, about what are the plans of the West, what are the plans of the developed countries, what developing countries are still doing, and what developed countries are thinking about. They are making plans and all about this. They are collecting the data about the number of the structures in their country or in their whatever, in their continent. They are collecting the data, how many years of the design left. And India is still making the new constructions, apartments and all that, without having any plan for the future. So the next thing is research and scope. What is the scope for the new generation of the India? What is the scope for in this field of the retrofitting and the rehabilitation? So it is being inferred that this RC jacketing, I told you, it is the most economical thing. But if the client budget is quite high, then you can go with a wrapping process like the carbon fiber reinforced process and this glass fiber reinforced polymer. So this is all about that, about the research being done by the PhD holders, about by the doctorates. So all this from the literature review, what the test conduct is in the lab, in off on field and the off field. It was concluded that the retrofitting of the concrete columns with carbon fiber reinforced polymer, as I told you, wrapping method can withstand large axial loads and impart high ductility as compared to the reinforced concrete jacketing process and ferrocement jacketing. So again, this about research and scope. This I am telling about this. For example, if any guy there, if any attendee is there doing any masters or bachelors, you have to done this project at the end of this degree. You have to submit the final project. You can. There's a lot of scope in this retrofitting and the rehabilitation. You can go ahead with this. There's a lot of scope. You can publish the papers. You can publish your research. You can write your review about this thing. There is a lot to do about. I mean to say, there is a lot of work to do about this retrofitting and the rehabilitation, and there is quite high scope about this for being a consultant engineer without looking for the jobs, without looking for the job, without going for interviews, without taking stress to that I'm jobless. I'm not. There is a lot of scope in this field. You can go ahead with being the consultant engineer if you have the skills, if you are good at grabbing the things. You can go ahead being you can go ahead with this field. There's a lot to do, a lot of things to do in this future. And I told you FRP, as I told you, the wrapping jacketing is much costlier as compared to here. And if client has the budget, Then you can go ahead with the carbon fiber reinforced polymer, and it can withstand high axial loads. Okay, so it is recommended to remove the concrete from the detail followed by sandwich to make the rough interface. So it is, as I told you, to prepare the surface. You cannot go for the retrofitting on the existing surface. You have to prepare the surface. You have to chisel it. You have to remove the damaged part, and then after that you can go ahead with the process. Whether you go with the wrap or whether you go with the jacketing. And the last point is most important, better to use different types of concrete in jacketing. As I told you, there are a lot of self-healing concrete. Nowadays, there's a kind of concrete in the trend, self-healing concrete. What does that mean, self-healing concrete? For example, if after 6 months, if 1 year, the concrete is showing some cracks, it will heal it automatically. It will heal by itself. There are some contents in the concrete. There are some contents in the material of the concrete that makes that heals automatically. That's why it's called self-healing concrete. And like that, there is self-compacting concrete. I told you there is non-compacting concrete. There are quite of sulfur concrete used in the offshore structures below the water. So lot of concrete types there are. Whatever as per the demand, we use the kind of concrete. So FRP jacketing, I told you, wrapping fiber reinforced polymer is an alternate for increasing the ultimate load carrying capacity and compressive strength, as it has the advantage of occupying less volume and the space. As I told you earlier that if you have the space available in the existing structure, then you can go with the economical thing. Then you can go with the economical technique, that is jacketing. You can increase the size of the column and you can go ahead. But if the space is very less, is constrained space, then you can go ahead with the wrapping process. So there is need to perform an additional experiment on different jackets even by using the and making proper bond size than normal can be compared. Yeah, it was already done by a lot of researchers that the normal RC jacketing was being compared with the carbon fiber reinforced, like glass fiber reinforced. But I have seen more than 5,000 research papers about this retrofitting and rehabilitation, but I did not see any paper about the comparison of normal RC jacketing with self-healing concrete. So you can go ahead with that thing. So about the career paths and the job prospects. About the career paths in the respective field of retrofitting and rehabilitation. As I told you that a retrofitting skillful engineer, if you have the skills, if you have the grabbing power to grab the things quickly, then no one can stop you. A retrofitting skillful engineer has the highly significant approach to achieve the aim of sustainability and productive by bringing down the cost of operation, because you are skillful. You are not dependent on anyone, and you can create higher investment return to the client. Because you being the engineer, you know the things how you have to do. You have how to perform the things, and the productivity of any employee plays an important role. And each company would, yeah, definitely, every company, if you go to any company as a being an employee, every company wants their employees to be productive. Why not? They are giving you salaries, they are spending money on you, they are spending hefty amounts on you. So every company, every employee, every sponsor wants their employees to be productive, so that they want good returns from them, definitely. But I told you that in India, it is still developing country. There's not any scope. There's not any kind of scope in the retrofitting and the rehabilitation. But in the developed countries have already started the process of collecting the data. See, there's a difference between the developed country and the developing country. They are already starting the process of the collecting the data, how many structures we have in the country, and how much design life is spending, and what we are doing in India. More than I think more than 90 skyscrapers in the Mumbai are already past the design life, and they are unsafe, totally unsafe, because we don't have any kind of planning. You being the youth, you being the next generation, you being the future of the India, you can go ahead with this process. You can make a groups, you can make 5 or 6 engineers together, you can make the group, and you can go ahead with the process. You can publish the research papers, you can establish a consultant firm. Nowadays everything is on the online. Definitely. So it has been it was being found that about more than 60% occupants who work in the environmentally certified buildings. What is the environmentally certified buildings? See, It's a mental fact. It is all about the mental fact. When you work, for example, when you work in the structure, you have some kind of fear in your building that no, I will not continue with this, that the structure is not safe like this. There are, for example, in the construction field, when the laborers are working at the top story, for example, they're working at 300 feet from the ground level, they have some kind of fear. Even the engineers, I have the fear. When I work in the apartment in the Mumbai, I was 200 feet from the ground, and I was helpless because there was no safety measures. So this is the thing, these things we have to work upon. We have to work on the safety things. We have to, there is a separate engineer, specific engineer for that part. It's called HSE, health safety engineer. We don't have these kind of things in the, that's why I told you, you being the future, you can go ahead with these things. You have the skills, you can go ahead with this part, because there is a lot of things to do in our developing country. One needs to work as a skilled engineer while performing. Definitely, as I told you, unskillful engineer can never be a rehabilitation and retrofitting engineer, can never be a repairing engineer, can never be a structural engineer. Unskillful, because you need the skills. You need the skills to perform the duties of any, not only the rehabilitation retrofitting, for the construction, for the design part, for any, for surveying part, you need the skills. Why not? India has the population of 1.3 billion. More than 10,000 engineering pass outs come every year. More than, I think, 1 lakh. Only the skillful will reach the top, and the rest will looking for the jobs and being stressed and not and continuing the studies without knowing that what to do next, what to do in the future. So this was all about. So think wisely about this, all these things.